All right, sorry about that. It got a little cut off, so let's pick right back up. So we will say we were talking about the prime factorization method. So the way they came up with this 2 times 3 and this 2 times 2 times 2 was by doing the factor trees that we learned about last week. So again, 6, you have 2 and 3. 8, you have 2 and 4, and then it goes down to 2 and 2. So remember that means that the prime factors of 8 are 2 times 2 times 2, and for 6, it's 2 times 3. So that's where they got these numbers. So then what you do is, and this is going to seem kind of weird, I'm going to go through it really quick. Let's list those factors again. We have 2 times 3 and 2 times 2 times 2. The way you do it is you take the factor. So if this is in both, you take it here. This is all, and then you have this one's not up there, so you list it again. This one's not up there, so you list it again, and 3 is not listed. But if you have the same factor, you only list it once. So that means that the lowest common denominator is 2 times 2 times 2 times 3, which equals 24. So again, you get the same thing every time, and we'll go through this one. This one really is one of the easier methods, the division and the prime factorization, for saving time. I like the division method the best, especially for bigger numbers, but you do need to know how to do this. The quiz will ask you to go through the steps, so I want to make sure it's really clear how you get this lowest common denominator from that prime factorization. So we'll go through some examples. So here, just a reminder of the process. So for method 1, you list the multiples for each, and you stop when you have the same multiple in common. Method 2 is the division method, similar to what we did for that factorization method last time. So what you do is you divide the denominators by the smallest prime number that divides at least one of the denominators exactly. If a denominator is not divisible by that prime number, rewrite the denominator as is. Then continue dividing each result until you end up with ones at the bottom. Build the LCD. So the LCD is those list of those prime numbers that you divided by. And then method 3 is the prime factorization of each denominator, and then you build the LCD. So remember, you just go through and find which ones are which ones listed. You take it for at least one time. I know it sounds weird. But it says the LCD is the product of each different factor, with each factor being used the most number of times it appears in any one factoring. I think going through some examples makes that clearer because the wording can be a little confusing. All right, important notes. The LCD is the lowest common multiple of the denominators. Ignore numerators when finding the lowest common denominator. Ignore negative signs when finding the lowest common denominator. Make sure you practice the prime factorization method. It is an important method for finding the lowest common denominators of algebraic functions. So let's go ahead and go do our own example. So we have find the LCD of the fractions. We have 5, 6, and 11 eighths, or excuse me, 11 18ths. And we're going to use method 1 and method 2. So let's first go through method 1. That's the listing multiples. So we're going to use method 1. So we have 6 and 18. So we have 6, 12, 18. Oh, I know what that's going to be. Right? So we know 18 is our least common denominator. Now, one thing I also want to show you, and you'll get more comfortable with this, if you see that one denominator is the factor of another, so like 6 divides evenly into 18, or 18 is evenly divided by 6, that means that that's going to be your lowest common denominator. You can just stop right there. If you have 10 and 5, you know your lowest common denominator is going to be 10. If you have 2 and 6, your lowest common denominator is going to be 6. So that's a little shortcut you can use down the road. So let's go ahead and do our other method. We have 6 and 18. So we're going to use the division method again. So here we have, I'm just going to write the fractions up here for ease of use, 11 over 18. And we're going to use the division method. So let's go ahead and write our prime numbers, right? We have 2, 3, 5, 7, dot, dot, dot. That's a terrible 7. If you thought I had bad handwriting before, try writing on an iPad. All right, so let's go. We have 6 and 18. So what do we start with? We start with 2, right? We go in order. 6 divides evenly by 2, so that gives us 3. And 18 divided by 2 gives us 9. 3 and 9 both do not divide evenly by 2, so we're done with 2. They both divide evenly by 3. 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. So now I know I'm done on this side. This side right here is done now that I'm at that 1. But I'm not done over here yet. So we need to divide by 3 again. And that's going to give me, we just carry that 1 down, and that 3 divided by 3, it gives me another 1. So that means I'm done. So that means that the lowest common denominator equals 2 times 3 times 3. Well, 2 times 3 is 6. 6 times 3 is 18. So again, we get the same answer that we got over here. We get 18. It's just a different way of getting there. So that's the other thing. If you need to use one specific method that's asked for on the quiz or the exam, that's okay if you want to check it with a different method. If you're not comfortable with one method, I still would like you to be really comfortable with these, all of them. But if you're having a hard time and you just want to check your answer, you can check it that way. All right. All right, so we're on page 49, your turn. So we're going to find the lowest common denominator of the fractions 1/10 and -7/45. Now, I'm looking at that, and 10 does not go evenly into 45. So I know 45 is not going to be my lowest common denominator. We're going to use the division method and the prime factorization method. And remember, it's specified here. So you'll see that in the problems. So we're looking at 1/10 and -7/45. And what did they say to do when we have a negative? We ignore it for now. So first we're going to start with the division method. So I'm just going to write division method. So we are given 10 and 45. We're going to put our division in. What do we start with? 2, 3, 5, 7. Right? Can we divide either one of those by 2? Yes. 10 is divisible by 2. Is 45 divisible by 2? No. So that means that 45 is just going to get carried down. 10 divided by 2 is 5. So we're going to write our other little division bar. Can either one of those evenly be divided by 2? No. What about 3? Well, 5 is not divisible by 3 evenly, but 45 is. So that means we're going to carry that 5 down, and 45 divided by 3 is 15. Hope I left enough room. 15. Now, 15 is also divisible by 3, so we're going to keep going here. That 5 gets carried down again, and 15 divided by 3 is 5. All right, now neither one of these is evenly divisible by 3, so we're done there. So now we're going to move on to 5. And both are divisible by 5, and we get 1. Once we get to that 1, we're done. Now we know our lowest common denominator is the multiplication of these numbers. So now we have 2 times 3 times 3 times 5. 2 times 3 is 6. 6 times 3 is 18. And I think 18 times 5 is 90. There we go. So our lowest common denominator here is 90. And now looking back, I can kind of see that because 45 times 2 is 90. And I know 10 is divisible by 90. So I kind of saw that coming. All right, let's look at the prime factorization method. So, and -7/45. So now we're doing prime factorization. I'm just going to write prime fact. There we go. All right, so what we need to do here first, we need to find our prime factors for both 10 and 45. So let's start here with 10. When we break that down, we have 2 and 5. Those are both prime, so we're done there. Then we have 45. Let's do 5 and 9. That's prime. 3 and 3, those are prime. So we know that our sets of factors are 2 times 5, and we have 3 times 3 times 5. Well, 2 occurs here, so we're going to write 2. There's 2 3s here, so we're going to write 2 3s. So those are done. And there's a 5s here, but since they both are there, we only write it once. Okay, because that cancels them both. So then our lowest common denominator here, like we just found, is 2 times 3 is 6, times 3 is 18, times 5 is 90. Again, we get the same answer, just with a different method of getting there. All right, so let's go down. Let's do another example like that. All right, so we're on your own part C. So let's go ahead and do 2 over 15 and 5 over 6. All right, so what method do we want to use? Let's try, why don't we go through two methods, even though it says one method of your choice. Let's go through two methods for practice. I would like to go through the division and the prime factorization, since those ones are the tougher ones to understand. So let's go ahead and start with the division method, just to show it. So we have 6 and 15, and here's our, what do we have? We have 2, oh gosh darn it. 2, 3, 5, 7, dot, dot, dot. So let's start with our 2, because 6 is divided by 2, that gives us 3. 15 is not divisible by 2, so we're just going to rewrite 15. Now, neither one of those is divisible by, oh, sorry guys, hold on, let me start this part over. Here, I'll show this part again. All right, so we have the division method. So we have 6 and 15. We have 2, 3, 5, 7. So we're going to start with dividing by 2. That's going to give us 3 here because 6 divided by 2 is 3. 15 we can't divide by 2, so we carry down. Now neither one of those is divisible by 2, so we're done with 2. We're going to move on to 3. 3 divided by 3 gives me 1, so that means I'm done on this side. 15 divided by 3 gives me 5. There's 1 we're done with, and 5 is not divisible by 3, so we're going to close out the 3. We're going to look at 5 now. We're carrying down the 1. 5 divided by 5 is 1, so we know we're done. So the lowest common denominator equals 2 times 3 times 5. 2 times 3 is 6, times 5 is 30. And I will say this is probably my favorite method. I feel like it's a one-step method. It's really clean, and the steps are easy to follow, for me personally. All right, so let's go through and do that using the prime factorization method. So again, we have 2 over 15 and 5 over 6. So the prime factorization, first we need to find our prime factors. So we have 6 gives us 2 and 3. Those are prime, so we're done there. 15, we have 3 and 5, so we're done there. That's pretty simple. So we have 2 times 3 and 3 times 5. Well, 2 is here, so we're going to write 2. The 3's are there together, so we only write it once, and then we write our 5. So again, our lowest common denominator is 30. Same answer, different method. Okay? If anyone has any questions about that, please let me know, okay? I will be more than happy to walk through that some more. And you have access to this. You can rewind it or go through it again. So let me know if you have any questions about that. All right, so the next thing we're going to talk about is how to write equivalent fractions. So to rewrite a fraction as an equivalent fraction with a different denominator, we must figure out what we need to multiply the original denominator by to get the new given denominator. We then multiply both the numerator and denominator by this factor. Remember, we can multiply by the numerator and denominator by the same number because that's the same thing as multiplying by 1, right? So in this example, we have 2/5, and we want to know what an equivalent fraction would be if the denominator was 30. So we need to look at this and say, okay, what do I need to multiply 5 by to get 30? Well, I know that 30 divided by 5 is 6, so that means I need to multiply this 2 by 6 also. So 2 over 5 times 6 over 6 equals 12 over 30. Again, in this one, you're trying to find this numerator and this new equivalent fraction. So what you do is you take this denominator 30, divide it by 5, and you get 6. So you know that you need to multiply 5 by 6 to get that 30. So then you also need to multiply the numerator 2 by 6 to get the new numerator. So that means that 12 over 30 is an equivalent fraction with 2 over 5. The process, identify the factor that is needed to change the original denominator into the given one. multiply the denominator of the original fraction by the missing factor, multiply the numerator of the original fraction by the missing factor. Important notes, if you're not sure what number to multiply the original denominator by to get the new denominator, divide the new denominator by the original one. So that's what I was explaining to you. So in this example, you could look at that and say, oh, I know I need to multiply it by 6 over 6. That's what I say, but it's not always so obvious. So in this case, they're saying the factor is 6 because 30 divided by 5 is 6. Remember, multiplying the numerator and the denominator of a fraction by the same value is okay because you're really multiplying by 1. The answer is, or the result is an equivalent fraction. In the next section, the new denominators will be the lowest common denominator. So what we're going to do is we're going to put together what we learned about lowest common denominators and writing equivalent fractions together so that we can add and subtract fractions that have different denominators. All right? So we're going to be putting this all together later. So let's look down here at your turn. We have rewrite the original fraction as an equivalent fraction with the given number. So here we have part A is 4/5 equals question mark over 40. So in this case, I need to go, okay, what do I need to multiply 5 by to get 40? Well, I know 5 times 8 is 40. So I could say 4/5 times 8 over 8. 4 times 8 is 32 over 40. So I know that this number is 32. So these are equivalent fractions. Now, if I didn't look at that and say, okay, well, I know I need to multiply by 8, I would say 40 divided by 5 equals 8, and that tells me what I need to do here to multiply. All right, let's look at part B. So we have 8 over 15 equals question mark over 120. So in this one, it's not as easy to see what the factor is. So we can use our calculator. We're going to say, what's 120 divided by 15? And that's going to give us equals 8. So ironically, our factor is 8 again. So we're going to say that 8 over 15 times 8 over 8, 8 times 8 is 64 over 120. So I know that that question mark is actually 64. That means that 8/15 and 64 1/20 are equivalent fractions. Okay, let's see. Let's do a couple more just to get familiar. So in part B, we're down on your own on page 51. We have 5 over 6 equals, question mark, I keep writing it too, sorry guys. Question mark over 24. Well, in this one, again, 6 is a multiple of 24. I mean, it's easy to see, it's 4. 4 times 6 is 24. So we would say 5 over 6 times 4 over 4 equals 20 over 24. So these are equivalent fractions. Now, you don't always have to write this step out. Oh, gosh darn it, guys. I'm sorry. Let me redo that part. Let me show you again. Okay. So we know that 6 times 4 is 24. So this is saying 5, 6 times 4 over 4 equals 20 over 24. Again, these are equivalent fractions. What I was just saying is that you don't have to write that step out if you can do it in your head very easily and you're not making mistakes. For those of you that this is coming as easily and you need to practice it, write that step in there. Make sure it's really clear you know what you need to do. All right, let's do part C. Maybe I can show it to you on the first try this time. 12 over 17 equals question mark over 85. Here we go. All right, so we have 17 and 85. Well, I don't really know what that is off the top of my head. So we're going to say 85 divided by 17 equals 85 divided by 17 gives me 5. All right, so now I know I need to multiply top and bottom by 5. So we have 12 over 17 times 5 over 5. Well, we already know the bottom's 85 from what we just did. 12 times 5 is 60. 60. So these are equivalent fractions. So that's how you go from equivalent from like one fraction to another. Again, we're going to take that piece, and then we're going to take the piece that we just learned in the last one about the lowest common denominator. And that way, now when we add or subtract fractions, we can find that lowest common denominator and write equivalent fractions to then add them. So that's it for 4.4. Let me go ahead and write those problems again for anyone that didn't get it in the chat this morning. So we have 4.4 problems are 7, 13, 17, 21, 23, 27, 31, 33, 39, 41, 43. All right, if you guys have any questions, you have a hard time with anything, reach out to me. Like I said, I'm looking into Zoom right now. I will get that set up as soon as possible. And if you need to schedule like a video chat, let me know. We can go through this. All right, I will talk to you guys all soon, hopefully. Take care.